October 3rd, 2025. Right now, a silent armada of orbiters circles Mars, their cameras fixed on a spectacle that defies the basic grammar of physics. In the thin light above the red planet, an object is venting 150 kilograms of gas every second without a hint of recoil. Imagine a cannon firing endlessly, yet the gun never shudders. That is the kind of violation staring back through the sensors. When the first data arrived, the teams on the ground didn't gasp, they checked for errors. Instruments must have failed, they thought, but they hadn't. Harvard astronomer Avi Loeb has marked it a 6 on his alien technology scale, a number high enough to stir whispers in control rooms. Yet the intrigue is deeper than a score. 2 days ago, a post surfaced on an obscure corner of 4chan, written by someone claiming ties to the European Space Agency. The message was raw, technical, even weary. It described a formal working group that has bent every known model trying to classify this visitor, and failed. What had once been a polite suspension of judgment has become, inside some circles, professional dissonance. They speak of chemistry that reads like satire. Nickel tetracarbonyl, a compound forged in human factories bleeding from a rock allegedly billions of years old. Dust so alien it took 7 days of recalibration before anyone dared call the measurements real. And then the mass, 33 billion tons compressed into a body barely 3 kilometers wide. The statistics are so absurd that either our galactic models are off by 4 orders of magnitude, or the thing is not debris at all. It gets stranger. In 26 days, the object slides behind the Sun, perfectly hidden from every terrestrial telescope. When it re-emerges in December, its course will tell the story. If the trajectory shifts, nothing natural can explain it. There is a theory, outrageous yet eerily neat, that stitches the anomalies together. A body with its own internal engine, not solar-powered but tapping energy from the universe's oldest storehouse, the Big Bang itself. 2 clear predictions will make or break that claim within 3 months. This is 3-1 Atlas, the third interstellar object ever found, and the first to make scientists wonder if they're staring at a comet or at something wearing a comet's mask. By the end, you'll see why some researchers are losing sleep, why the timing feels choreographed, and what's at stake if the data refuses to yield. The walls of our understanding are cracking, and through the fractures, a new shape is beginning to show. Chapter 1. The Mars Moment. Something is unfolding now, not tomorrow, not in some distant age when we finally build the perfect telescope or send the ultimate probe, but in this very hour, October 3rd, 2025. At this precise moment, humanity has an armada of spacecraft orbiting Mars, and every single one is directing its gaze toward the same enigmatic target. That target is 3I Atlas, the third confirmed interstellar object ever to pass through our solar system. At 4 o'clock Universal Time this morning, it swept within 29 million kilometers of Mars, its closest brush with any planet on this brief journey through our celestial neighborhood. The timing could not be more critical. Let me explain why. For 3 months, scientists have strained to follow this visitor from Earth. The Hubble Space Telescope caught images. The James Webb Space Telescope dissected its chemical fingerprint. Dozens of observatories across the globe traced its path. Yet all of that shared one weakness: distance. When Hubble captured 3I Atlas on July 21st, it hovered some 446 million kilometers away, nearly 3 times the span that separates Earth from the Sunday. Even Hubble's exquisite eye could only reduce the alien intruder to a hazy smear of dust and light. Today, everything changes. The Mars Reconnaissance Orbiter, carrying the famed HiRISE camera, now observes from 20 times nearer than Hubble did in July. The leap in resolution is profound. Where Hubble could only hint at a diffuse glow, HiRISE has the potential to discern features as fine as 30 kilometers per pixel. If calculations placing the object at 5 kilometers or more in diameter prove correct, this means structure, outline, perhaps even surface detail should emerge. Europe, too, has trained its fleet. Mars Express and the ExoMars Trace Gas Orbiter have swung their instruments toward the Wanderer. Mars Express carries a high-resolution stereo camera. ExoMars holds the color and stereo surface imaging system. Both were built to map the Martian terrain, yet for this fleeting window their attention has shifted to something far stranger. Then come the spectrometers, Omega and Spicum aboard Mars Express, Nomad aboard ExoMars. These tools do more than capture images, they fracture light into its hidden wavelengths, teasing out chemistry and thermal state. From such data, researchers can tell whether the shimmering cloud is born of ice sublimating into space, or whether something altogether unfamiliar drives the activity. The hope, the cautious, official hope, is that these observations will begin to answer simple but profound questions. How large is the nucleus in truth? Does it spin, and at what pace? What is the architecture of the dust cloud when seen up close? And above all, is this only a comet, albeit one behaving in extreme ways, or are we facing an object that belongs in a category of its own? Here lies the tension. From its initial brightness alone, when 3I Atlas was first spotted in July, astronomers speculated it might span as much as 20 kilometers. Soon, improved data from the Vera Rubin Observatory revised the guess downward to 10. Hubble's late July scrutiny reduced it further, perhaps 5.6. Depending on reflectivity models, some estimates sink as low as 440 meters. The range is staggering, the difference between a sprawling city and a single skyscraper, and the stakes are immense. If 3I Atlas truly measures 5 kilometers or larger, it would be the most massive interstellar visitor ever recorded, eclipsing all predecessors by a vast margin. Oumuamua, the first, was a fragile shard about 100 meters across, pancake-shaped and tumbling. The second, 2Y Borisov, stretched perhaps 600 meters, a comet that looked familiar, if foreign. But 5 kilometers? 33 billion tons of alien mass bearing down through the solar system? That is not just large, it is statistically outrageous. Let me place this moment in perspective. According to our current models, the galaxy should be awash with tiny wanderers rather than giants. For every mountain-sized body cast out from a distant solar system, there ought to be tens of thousands of fragments, no larger than boulders or pebbles, perhaps hundreds of thousands. Probability alone dictates that if we were ever to glimpse visitors from the deep interstellar void, the first to arrive in our telescopes should be small ones. Statistically, they vastly outnumber the Titans. Yet what have we actually found? 3 interstellar objects, and now the third appears not just larger, but potentially 1,000 to 1,000,000 times more massive than the first. That runs backwards against every expectation. Unless, of course, our models are flawed, unless the galaxy is not merely dotted with stray debris, but crowded with it, swarming in densities we never dared consider, unless the processes that fling matter from their home systems do not work as we thought, or, and this is the darkest possibility, unless this body is not natural debris at all. That is the central question these Mars observations must confront. Should HiRISE capture an image revealing a 5-kilometer nucleus, the mass calculations will hold. 33 billion tons becomes a fixed lower bound, and at that moment the statistical contradiction hardens into something we cannot dismiss. But if the image reveals something smaller, perhaps a kilometer or less, the puzzle only shifts. A nucleus that small, glowing with such brightness and shedding such torrents of gas, would be unlike any comet on record at this distance from the Sunday. Either outcome points to something beyond the ordinary, and yet here is the agonizing truth. We will not know instantly. Every packet of information must cross the gulf back to Earth, be decoded, calibrated, tested. The European Space Agency has already tempered expectations, warning that neither Mars Express nor the ExoMars Trace Gas Orbiter were designed to stare outward at the heavens. At 30 million kilometers, 3i Atlas registers as less than a single pixel on their cameras. At best, they may glimpse the halo of escaping gas, perhaps the ghost of a tail, but not the nucleus itself. HiRISE remains the real hope, though even here the timeline is uncertain days, perhaps weeks, before images can be cleaned, processed, and shared. Meanwhile, the object does not wait. It races onward. By mid-October, 3i Atlas will slip too near the Sun to be seen from Earth. The glare will blind every telescope. On October 29th, it reaches perihelion, just 4 astronomical units from the Sun, inside the orbit of Mars. For 26 long days it will vanish, hidden on the far side of the star, unobservable, untouchable. Only in early December, returning in the pre-dawn sky, will we once again trace its arc, measure its glow, and learn whether it behaved like an ordinary comet or carried out some more unsettling performance. But before we leap ahead, we must hold on to the present October 3rd, the Mars moment. For while the official focus is squarely on resolving the size of the nucleus, there is another layer unfolding, a subtler tension rooted not in what the cameras may reveal, but in what the data has already begun to whisper. And it is in that whisper where the cracks first begin to show. Chapter 2: The 7 Sins Against Nature. On October 3rd, the very day 3i Atlas brushed closest to Mars, Avi Loeb chose his moment. He released an article that framed the debate in stark, almost biblical terms: the 7 anomalies of 3i Atlas. Not curiosities, not loose ends awaiting clarification. Anomalies, outright violations of what an interstellar comet ought to be. He sorted them into 2 categories. The first, a group of 4 that might, at least in theory, be softened by new data. The second, 3 that he warned would remain troubling forever, because they are not about missing information but about probability, timing, and trajectories that resist any natural explanation. Let us begin with the first category, the anomalies that might yield to reason. Anomaly 1. Size. We have touched on this already. Measurements suggest a diameter exceeding 5 kilometers, translating to a minimum mass of 33 billion tons. That makes 3i Atlas between 1,000 and 1,000,000 times heavier than either of its predecessors. Could new data shrink that figure? Possibly. If today's Mars observations reveal a smaller nucleus, the problem eases. But if the size holds or grows, then the statistical contradiction hardens into something deeply unsettling. Anomaly 2. The jet. Hubble's images show something uncanny. A forward jet of scattered sunlight, 10 times longer than it is wide, aimed squarely at the Sunday. Cometary tails almost always sweep away from the Sun, pushed back by radiation pressure and the solar wind, yet this jet seems to defy that rule. The suggested explanation is outgassing from the sunward side, where fresh material bursts free, scattering light before being forced back. Reasonable, on paper, but 2 details nag. The jet appeared far earlier than expected, at distances where most comets slumber in silence, and it persisted with extraordinary brightness. Only by late August did a conventional tail emerge, and even then it lagged the timeline. The implication is unsettling. The physics of outgassing here are not behaving like any comet we know. Anomaly 3. Chemistry. Here, the strangeness deepens. Spectroscopic readings from both the James Webb Space Telescope and the Very Large Telescope revealed a plume dominated by nickel, not iron. In comets, whether homegrown or even in 2I Borisov, the previous interstellar visitor nickel and iron tend to appear in solar-like proportions, their ratios balanced much as in the Sun itself. But Atlas defies this balance. Nickel has been visible in every observation epoch. Iron, by contrast, appeared only when the object moved within 264 astronomical units, and even then, nickel outweighed it dramatically. Why does this matter? Because both nickel and iron are refractory metals. They are not supposed to vaporize at the low temperatures typical of comets. Even when Atlas crept inward toward the Sun, its surface remained too cold for raw nickel to simply sublimate into gas. Something else must be at work. Perhaps a parent compound, a nickel-bearing molecule unstable enough to disintegrate under heat, releasing nickel into the surrounding space. Or perhaps the heating mechanism itself is unconventional, driven by physics we have not yet grasped. These are the explainable anomalies, the ones that optimists hope will resolve as the data improves. Yet each, even in its provisional state, strains the boundaries of our understanding. And Loeb's article warns, the next category, the final three, are not about imperfect data at all. They are about chance, coincidence, and patterns that refuse to look random. Either way, the picture remains puzzling. And the strangeness does not stop there. The chemistry of the gas is unusual as well. Most comets, as they near the Sun, become dominated by water. Ice sublimates, vapor fills the spectrum, and water lines drown everything else. But 3I Atlas does not play by that script. Its coma is rich in carbon dioxide. The ratio of carbon dioxide to water is 8:1, among the highest values ever measured. Such a balance implies a birthplace in an environment unimaginably cold, far colder than the regions where ordinary solar system comets are forged. Anomaly 4. Polarization. This one is subtle, technical, yet deeply revealing. When light bounces off dust grains, it acquires polarization. By studying that polarization, its angle, its intensity, scientists can infer the nature of the particles themselves, their size, their shape, their roughness. Across decades of work, every comet and asteroid observed has fit neatly into a predictable range. 3I Atlas shatters that pattern. The polarization data landed so far outside the known spectrum that researchers suspected instrument failure. They repeated the observations. The results were the same. The implication is stark. The dust is fundamentally unlike what we are used to. Not silicate sands, not crystalline water ice, something different. Large, complex, porous grains, more akin to smoke than to stone, fragile webs of matter adrift in sunlight. These four anomalies, the size, the sunward jet, the nickel-rich chemistry, the smoke-like dust, are strange, yes, but not fatal to the comet hypothesis. Each could, in principle, bend to explanation. Better data might revise the size. Outgassing asymmetry could create the jet. Exotic parent molecules might explain the nickel. Unusual formation conditions might yield odd dust grains. Uncomfortable, but still within the wide net of nature. But then comes the second category, the permanent mysteries. These are not about missing data. They are about chance itself. Anomaly 5. Trajectory alignment. The path of 3I Atlas, through our system, is aligned to the ecliptic plane within 5 degrees. The ecliptic is the great flattened disk where the planets revolve around the Sunday. For interstellar objects arriving at random from the galaxy, inclinations should scatter wildly steep, shallow, even retrograde. The odds that a visitor would arrive with such a tidy alignment are about 0.2%, 1 in 500. Not impossible, but improbable enough to raise the first serious red flag. Anomaly 6. Arrival timing. Here the odds collapse altogether. 3I Atlas has not only arrived on a trajectory aligned with the planets, but at a moment that allows close approaches to Mars, Venus, and Jupiter in sequence. Mars today, October 3rd. Venus could have been reached in July with only minimal adjustments. And in March 2026, Jupiter lies within reach. The probability of an interstellar body arriving by sheer accident on a path and schedule that permits this chain of encounters, roughly 0.005%, 1 in 20,000. Consider that for a moment. When engineers design probes to tour a solar system, they craft precisely this kind of trajectory. Voyager, Cassini, New Horizons, all used planetary flybys, gravitational assists, and carefully timed arrivals to maximize efficiency. If you wanted to design a craft to visit multiple planets here, you would do exactly this. Align with the ecliptic, arrive when the planets line up, minimize the energy needed for course corrections, and that is what makes this anomaly so unsettling. 3I Atlas looks less like a wanderer and more like something delivered. Chapter 3. The Impossible Physics. 2 days ago, the story of 3I Atlas took a darker turn. On October 1st, 2025, a new thread appeared online, not on Arxiv, not on a reputable astronomy forum, but on 4chan's paranormal board, a place usually devoted to cryptids and conspiracy lore. Yet this post was different. It was written in the voice of someone claiming to be a PhD researcher with the European Space Agency. The author insisted they had direct access to combined observational data for 3I Atlas, that they belonged to a formal working group assigned to decipher it, and that the group had failed. Their words were blunt. For months, I have been part of a formal working group that has tried and failed to reconcile this object's behavior with any known class of natural celestial body. The official position is that 3I Atlas is a uniquely active but otherwise natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for a growing number of us. Now, let's be clear. Anonymous claims on 4chan are not peer-reviewed science. They are not verified, and they can be elaborate fictions, roleplay, speculation, mischief, dressed in jargon. But what set this apart was its texture. The technical detail was sharp, the frustration palpable, and the narrative dovetailed with publicly released data, while adding context not seen in official channels. So let us treat this not as fact, but as a window, a glimpse of how some scientists might be wrestling with data that refuses to fit. The post began without gassing. According to the anonymous source, 3I Atlas is venting roughly 150 kilograms of gas and dust every second. This is not rumor, it is measurable. The James Webb Space Telescope recorded it. Spectrometers at the Very Large Telescope confirmed it. The object is bleeding mass continuously, carbon dioxide, water, ice, grains of dust, an endless torrent, and yet, according to the researcher, nothing happens. It feels like a mistake in the data, until you've checked it 100 times with all the available instruments. The object is venting about 150 kilograms of gas and dust every single second. We see it, yet it does nothing. It's like watching a howitzer fire a shell with absolutely zero recoil or smoke or bang. It's a constant violent event with no consequences, and that is a disgusting violation of basic physics. Here lies the paradox. When a comet outgasses, it recoils. This is Newton's third law, carved into the very bones of mechanics. Every action has an equal and opposite reaction. Jets of vapor stream outward. The nucleus shifts ever so slightly in response. Over days and weeks, this produces a detectable effect known as non-gravitational acceleration, a subtle drift from the pure curve of gravity's pull. Every active comet we know obeys this rule. Halley's Comet, Hale-Bopp, even 2I Borisov, the last interstellar wanderer, all showed measurable deviations as their gases boiled into space. 3I Atlas does not, or at least, almost not. In September, a paper by Richard Cloyt, Avi Loeb, and Peter Veers analyzed precisely this question. They gathered 4,022 positional observations from 227 observatories worldwide, spanning months of tracking. The team calculated the orbit of 3I Atlas with exquisite precision. Then they searched for signs of deviation residuals, small errors in fit, the telltale fingerprints of thrust. What they found would sharpen the riddle. The September paper put a number to the puzzle. Across months of observations, the upper limit on non-gravitational acceleration came back at just 0. 0.028 arc seconds. That translates to less than 15 meters per day, squared, essentially zero. For an object venting 150 kilograms of material every second, that is impossible. According to the anonymous researcher, the only way the math balances is if the object is far more massive than it appears. The only way the physics works is if the object has the mass of a small moon crammed into a body no more than 2 to 3 kilometers across. The lower models give us a limit of 33 billion tons, which just creates a second, worse problem. Finding a mountain on an interstellar trajectory is statistically impossible. Pause on that image. If 3I Atlas really resists recoil while hemorrhaging gas, it must be incredibly dense. Not ice, not porous rock, something closer to iron. A 3-kilometer sphere of nickel-iron metal would yield roughly that mass. Yet the intruder wears a comet's mask, a coma, a tail, jets of vapor. Somehow it combines the density of an asteroid core with the volatility of a frozen nucleus. That contradiction alone destabilizes our models. The Post pressed further. Our surveys have only just begun. To find an object this massive this early means the galaxy is not dotted with debris, but swarming with it. The models are wrong by a factor of 10,000. Our picture of what gets ejected from solar systems is grotesquely flawed. Or this object is not debris at all, and that is the quiet and terrifying conclusion we are being discouraged from discussing. Let that sink in. If the mass is truly 33 billion tons or greater, then the statistical framework fractures. Big interstellar bodies should be exponentially rare. For every mountain-sized rock, millions of smaller shards should arrive first. Yet our record shows 3, a pancake-shaped fragment scarcely 100 meters across, a relatively normal comet a few hundred meters wide, and now an object perhaps 1,000 times more massive. The sequence is inverted. Either we are impossibly lucky, or the galaxy teems with massive wanderers at scales far beyond prediction. And if neither of those are true, then we confront a third, more unsettling option. 3I Atlas is not natural debris at all, and the chemistry only deepens the unease. The gases defy expectation. Spectra reveal pure atomic nickel streaming into space at temperatures where it should remain locked solid. It does not rise gradually like water ice sublimating to vapor. It behaves like a switch nickel emission flaring on with sunlight, shutting off with the faintest dip in heat. Such hypersensitivity can only mean one thing: decomposition of a parent molecule. And the only candidate that matches the data is nickel tetracarbonyl. This name may sound arcane, but its history is entirely human. Nickel tetracarbonyl, a compound of nickel bound to 4 carbon monoxide groups. At room temperature, it is a colorless liquid, highly toxic, dangerously volatile. Discovered in 1890 by Ludwig Mond, it became the cornerstone of the Mond process, an industrial method for refining nickel. Feed pure nickel into a chamber of carbon monoxide under specific conditions, the compound forms. Heat it again, and it breaks apart, depositing purified metal. In other words, it is synthetic. It does not occur naturally on Earth. And yet, according to this anonymous researcher, it is the only explanation for the nickel signature streaming from 3I Atlas, the extreme temperature sensitivity, the abrupt on-off behavior, the absence of iron. But this creates a new paradox. If this object is billions of years old, born in some distant protoplanetary disk, what is a laboratory compound doing in its atmosphere? Natural processes do not generate nickel tetracarbonyl. They require high-pressure carbon monoxide interacting with metallic nickel under controlled conditions. Even if such conditions existed briefly in the early solar system, the compound is unstable. It breaks down quickly. It cannot survive for billions of years drifting through interstellar space, unless, of course, it is being made right now. Unless nickel tetracarbonyl is actively produced within 3I Atlas. And that possibility forces an even stranger question. Produced by what? That was the question hanging unspoken. The anonymous post then shifted from chemistry to dust. And here, too, the story twisted. We measured dust by the way it scatters light, its polarization. From that, scientists infer the texture of the grains, their shape, their porosity. In every comet, in every asteroid, the results fall within a familiar band, consistent and predictable. 3. Atlas broke that pattern so badly the team's director assumed the observers were making mistakes for an entire week. They checked again, same numbers. The only way to reconcile the data was to admit the dust was fundamentally different. Not ice crystals, not silicate sand, something else. Large, complex particles, dark and porous as smoke. It's not natural dust, the poster wrote. It's a manufactured material. The phrase rang like a gunshot. Manufactured material. The physics was wrong. The chemistry was wrong. And yet it was all internally consistent. A system of wrongness as if deliberately crafted to force doubt. We do, in fact, have public data on this anomaly. In September, a paper was published analyzing optical polarimetry from multiple telescopes. It measured a polarization degree of -2.1% at a 90-degree phase angle. Negative polarization at that geometry is extremely rare. It means the light waves were polarized perpendicular to the scattering plane, something that only happens with particles of highly irregular shape and intricate internal structure. The paper called it unusual, but stopped short of declaring it impossible. According to this supposed insider, internal discussions went further. The results were so far outside the norm that error seemed the only explanation. Yet repetition confirmed it. If the grains are large, porous, and complex, that implies a formation mechanism unlike any comet we know. Normally, comets shed micron-sized dust when sublimating ice lifts particles from the surface. The grains are relatively simple, silicate or carbonaceous, the stuff of primitive rock, but porous smoke particles, that is something else. Aerosol-like, with immense surface area relative to volume, the kind of material produced in combustion, in industry, or in processes that grind solids into ultrafine powders, not from ice sublimating gently off rock. And then came rotation, or rather, the absence of it. Hubble and Webb see a feature that shouldn't exist, the post claimed. A faint, greasy smear of a tail pointing directly at the Sunday. Supposedly, a massive carbon dioxide jet is erupting from the sunward side, strong enough to loft heavy grains of water, ice grains that sunlight alone could never push. A directional engine. Fine, but the object doesn't rotate. We've watched it for days, the researcher insisted. Its brightness curve is a flat line. No flicker, no pulse. A jet that violent, on a rotating body, should produce rhythm brightness variations as the jet spins into and out of view. Instead, absolute stillness, perfect, unwavering light. One side of the evidence requires asymmetry, the other demands perfect symmetry. You cannot have both. Either the model for the tail is wrong, or that cloud is not natural. This matters because cometary rotation is one of the most reliable signatures we have. Active comets pulse. Their light curves rise and fall as the nucleus turns, exposing different regions to the Sunday. 3I Atlas does not. According to the alleged insider, its brightness remained constant, dead flat. That leaves only two possibilities. Either the object does not rotate at all, almost inconceivable for something that has spent billions of years colliding, grazing, spinning through gravity wells, or the object somehow maintains perfectly symmetric outgassing, ejecting material evenly in all directions every second, but that symmetry contradicts the observed forward tail. A jet demands a symmetry, a flat brightness curve demands balance. The only way out is a decoupled coma, a cloud of dust and gas regulated independently from the spinning nucleus, or an active mechanism controlling surface activity to enforce uniform brightness. Neither is natural. And then came the heat. The thing is cold, the researcher wrote. It is absorbing gigawatts of solar energy power, enough to run a small city, yet radiating none of it away in the way a comet should. The thermal budget does not close. Sunlight pours in. Where does it go? Normally, for a comet, the answer is simple. Energy in equals energy out, plus or minus whatever gets stored. Sunlight strikes ice. Ice sublimates into vapor, carrying energy away. Radiation bleeds the rest into space. But not here. 3I Atlas is drinking sunlight and refusing to warm. It should be venting water in colossal plumes. Instead, the water is missing. It is as if you held a blowtorch to an ice cube and watched it stay frozen. The surface remains locked at a low, stable temperature, as though the object has found a way to dispose of, or regulate, an immense thermal load without melting. That is not supposed to happen. Not in any natural system, not in physics as we understand it. This is how comets keep their cool. Sublimation acts as a natural heat sink. Sunlight strikes ice, the ice vaporizes, and the phase change carries energy away. But with 3I Atlas, the ledger will not close. It is absorbing gigawatts of raw solar power and yet releasing far less water vapor than the models demand. Where is the surplus heat going? According to the anonymous researcher, every thermal model fails. There is a missing sink energy that should be driving furious activity, but is invisible in the expected emissions. One possibility is albedo. Perhaps the surface is so reflective that most sunlight bounces away. But if that were true, the object would blaze brighter than it does. Another possibility is that heat is seeping into the interior, stored deep within the bulk. Yet that would require thermal conductivity far higher than any icy matrix can offer. A third option is that the energy escapes as radiation in wavelengths we are not measuring far infrared, submillimeter. And the fourth is the most unsettling, that the surface temperature is being actively regulated. Absurd on its face, and yet the data whisper exactly that. And then there is the path it took to get here. Its trajectory is a statistical joke, the poster wrote, a perfect low angular momentum orbit that guarantees a close pass. There is no known natural process that filters massive objects onto such tracks. This wasn't just a random encounter. For all intents and purposes, this thing was delivered from the darkness. We have already spoken of its ecliptic alignment, of its timed encounters with Mars, Venus, and Jupiter, of probabilities collapsing into red flags. This adds another layer. Low angular momentum means not only is the orbit coplanar with the planets, it is moving relatively slowly by interstellar standards. Most interstellar interlopers rip through our system at tens of kilometers per second. Oumuamua tore past at 26 kilometers per second, relative to the Sun a blur. 3I Atlas, in interstellar space, traveled about 60 kilometers per second. But at close approach, accounting for the Sun's gravity, its speed becomes low, manageable almost as if the trajectory had been tuned to linger. The post closed with a unifying statement that read like a warning, "You don't get it." None of these are separate problems. They're all symptoms of a single underlying sickness. A jet powerful enough to make the tail would make the object flicker. It doesn't. A body that massive should be dead. It isn't. The sun's heat should be boiling it alive. It feels nothing. Each paradox is a wall, and we're all standing here staring at the walls, refusing to see the shape of the room. This isn't a failure of our models. This is a glimpse of the machinery running underneath them, and it's wrong. A glimpse of the machinery running underneath. The phrase is haunting. It suggests the anomalies are not bugs, but features that the object is not broken but operating under rules we do not yet understand. And then, at the end, the researcher offered an explanation, one that sounds like pure science fiction, but that, in their view, is the only physics that renders all the data coherent. Chapter 3. The Impossible Physics. 2 days ago, the story of 3I Atlas took a darker turn. On October 1st, 2025, a new thread appeared online, not on RxIV, not on a reputable astronomy forum, but on 4chan's paranormal board, a place usually devoted to cryptids and conspiracy lore. Yet this post was different. It was written in the voice of someone claiming to be a PhD researcher with the European Space Agency. The author insisted they had direct access to combined observational data for 3.1 Atlas, that they belonged to a formal working group assigned to decipher it, and that the group had failed. Their words were blunt. For months I have been part of a formal working group that has tried and failed to reconcile this object's behavior with any known class of natural celestial body. The official position is that 3I Atlas is a uniquely active but otherwise natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for a growing number of us. Now, let's be clear. Anonymous claims on 4chan are not peer-reviewed science. They are not verified, and they can be elaborate fictions, roleplay, speculation, mischief, dressed in jargon. But what set this apart was its texture. The technical detail was sharp, the frustration palpable, and the narrative dovetailed with publicly released data while adding context not seen in official channels. So let us treat this not as fact, but as a window, a glimpse of how some scientists might be wrestling with data that refuses to fit. Chapter 4. The Chemical Nightmare. Now let us confront the most disturbing layer of all, the chemistry. What is actually streaming off this object? According to the leaked post, it is not just unusual, it is impossible. The nickel story begins with temperature. Between August and September, the Very Large Telescope turned its UV spectrograph on 3.1 Atlas. It detected spectral lines not from nickel compounds, but from pure atomic nickel glowing in the coma, present at every observation epoch. And here lies the paradox. Nickel is refractory. Its melting point sits at 1,455 degrees Celsius. Its boiling point climbs to nearly 3,000 degrees Celsius. Yet when these detections were made, the comet lay between 3.1 and 2.1 astronomical units from the Sunday. At that distance, the expected surface temperature ranges between 100 degrees Celsius and 50 degrees Celsius frigid, nowhere near the threshold for nickel grains to vaporize into atomic gas. And still, nickel appeared in measurable amounts, pouring into space. The official literature approached this carefully. One paper admitted, the presence of nickel and iron atoms in cometary comae is extremely puzzling. At the distances at which comets are observed, the temperature is far too low to vaporize silicate, sulfide, and metallic grains that contain nickel and iron. The authors speculated about a parent molecule, some nickel-bearing organic compound, breaking down under solar light, but they did not name it, and for good reason. In nature, nickel forms few volatile compounds. It is chemically stubborn, preferring the solid state. The alleged insider, however, supplied the missing name, nickel tetracarbonyl, and that is where the nightmare begins. Nickel tetracarbonyl belongs to the class of organometallics, one nickel atom bound to 4 carbon monoxide groups. At room temperature, it is a colorless liquid, highly volatile, with a boiling point just 43 degrees Celsius. Most importantly, it is photosensitive. Under ultraviolet light, the kind the sun produces in abundance, it falls apart. Carbon monoxide groups peel away, leaving free nickel atoms in their place. This would explain the data with uncanny precision. Nickel tetracarbonyl on the surface sublimates gently when warmed. Its vapors drift into space, where ultraviolet photons strike and disintegrate the molecules, leaving behind nickel atoms that glow in the spectrum. Even the sharp sensitivity fits. The production rate of nickel increases with solar distance to the 9th power, far steeper than ordinary sublimation. That is exactly the kind of abrupt dependence one would expect from photodissociation. So yes, the chemistry fits, but the problem is existential. Nickel tetracarbonyl does not occur in nature. It is a synthetic compound. Humanity manufactures it in refineries through the Mond process, patented in 1890. The recipe is simple but precise. Expose metallic nickel to carbon monoxide gas at high pressure and moderate temperature. The compound forms. Transfer it to a different chamber. Heat it again. It breaks down, leaving purified nickel. This is an industrial refining technique, not a process found in wild space. So how does a synthetic refinery chemical appear on an interstellar comet? One possibility, distant but not unthinkable, is that such conditions exist somewhere in protoplanetary disks. Carbon monoxide is abundant. Metallic nickel grains float in their dust. If the pressure and temperature aligned just so, perhaps nickel tetracarbonyl could form. Not impossible, but deeply improbable. And even if it did, the compound is unstable. Radiation decomposes it quickly. Over billions of years of exposure to cosmic rays, any primordial reservoir would vanish, which leaves only one alternative. It is being made now, actively, continuously, within 3I Atlas itself. That is the suggestion, whispered in the leak. The object is not carrying ancient residues of a volatile industrial compound. It is generating them as a byproduct of whatever mechanism drives it from within. And then comes the final twist in the spectra. Where nickel dominates, iron vanishes. In ordinary comets, nickel and iron appear hand in hand, echoing their shared abundance in the Sunday. But here, one is present without the other. In normal cosmic chemistry, nickel and iron walk hand in hand. In the Sun, in meteorites, in the dust of protoplanetary disks, their ratio holds steady, roughly 1 nickel atom for every 20 of iron. That is the cosmic abundance, the fingerprint of stellar nucleosynthesis. But in 3I Atlas, the fingerprint is smudged. Nickel dominates in excess, far beyond balance. Iron was absent altogether until the comet closed to within 2.64 astronomical units. Even then, the ratio remained skewed, nickel outshining iron by an order of magnitude. Why? If both metals are locked into the object's structure, why does one sublimate freely while the other stays hidden? The insider's explanation circles back to the same culprit, nickel tetracarbonyl. Iron lacks a parallel. Iron pentacarbonyl exists, but it is unstable, reluctant to form under comparable conditions. Thus, if an active process is generating tetracarbonyl in abundance, nickel would flood into space while iron remains trapped. Selective chemistry, deliberate, intricate, far removed from the crude release of dust and gas that comets normally display. And then comes the dust, and here the data crosses from strange into outright surreal. Polarization is a standard diagnostic in astronomy. When light scatters off particles, it polarizes, and the degree and angle of that polarization betray the particle's nature, its size, its shape, its composition. Every comet ever studied, every asteroid, falls somewhere inside a known band. Silicate grains, carbonaceous dust, icy fragments all vary, but within limits. 3I Atlas lies outside those limits. Public data recorded polarization at a 90-degree phase angle of -2.1%. Negative polarization at that geometry is not just rare, it is almost unheard of. It requires particles of extreme irregularity, chaotic shapes, labyrinthine interiors. When the measurements first arrived, the reaction was disbelief. Our director insisted we were messing up for the best part of a week until we repeated the result. The leaked post recounts. The instruments were checked, recalibrated, tested. The numbers held. The only explanation, the insider claimed, is that the dust grains themselves are not natural, not fragments lifted gently off a frozen surface by sublimating ice. Something else entirely. Large, incredibly complex particles, black and porous as smoke. Consider what that means. Typical cometary dust is micron scale, a few micrometers across simple grains, bright enough to scatter sunlight. But large, porous, complex particles point to aggregation, fluffy structures riddled with voids, with high surface area and low density, almost like soot or industrial aerosol. That is the kind of dust you see from combustion or from chemical vapor deposition, where matter condenses atom by atom into delicate, layered webs, processes that build particles with intricacy, processes that do not happen on a frozen, natural rock. And then there is the color. Ordinary comet dust is relatively reflective. That reflectivity is why comets shine so dramatically in our skies. But the dust of 3I Atlas, if the description is true, is black, light-absorbing, thermally efficient. Black dust soaks up sunlight, warms quickly, radiates strongly in the infrared. If the grains surrounding 3I Atlas are both porous and black, they would become efficient sponges for solar energy, which loops us back, inexorably, to the thermal paradox. Where is all that energy going? The insider framed it in one damning sentence: the chemistry is wrong, the physics is wrong. It is a perfectly self-consistent system of wrongness, as though its whole purpose is to make us doubt ourselves. Self-consistent, that is the phrase that lingers. Each anomaly, in isolation, could be stretched into an explanation, an exotic parent molecule, a rare outgassing geometry, an odd scattering of light. But together, they form a system, a coherent, seamless tapestry of impossibility. Taken one by one, these traits are unusual, but still within the realm of possibility. But together, they begin to form a system, a coherent picture, just not one that fits the natural comet hypothesis. It is like examining a machine in which every part is slightly off-spec, yet the machine runs smoothly. You start to wonder whether the specifications are wrong, or whether the machine was built to different standards entirely. And here it is necessary to be clear. The official scientific position, the one publicly endorsed by most astronomers, is that 3I Atlas is a comet. An unusual comet, yes, with properties that stretch the edges of what we have seen before, but still a comet, still explainable within the framework of planetary science. NASA has said so explicitly. Tom Statler, NASA's lead scientist for solar system small bodies, told reporters, "It looks like a comet. It does comet things. It very, very strongly resembles in just about every way the comets that we know." He is not wrong. 3. I Atlas has a coma. It has a tail. It outgasses as it approaches the Sunday. These are comet behaviors. But the devil hides in the details, in the chemistry, in the dust, in the thermal balance. That is where the questions live. The insider's post does not claim certainty. It does not declare, "This is alien," or "This is artificial." Its message is simpler and, in a way, more unsettling. For months, I have been part of a formal working group that has tried and failed to reconcile this object's behavior with any known class of natural celestial body. Failed. Not, "We're still working." Not, "We need more data." Failed. That is the word they used. If this leak is genuine, if it reflects real internal conversations within the European Space Agency's working group, then there are scientists who have stared at this data and privately concluded they do not have an answer. And that raises the real question. If the standard explanations do not work, what does? It is at this point that the post veers into stranger territory, a domain that sounds like theoretical physics or, depending on one's generosity, like science fiction. Chapter 5. The rotation that doesn't exist. Every body in space spins. It is as inevitable as gravity. Collisions impart angular momentum. Gravitational encounters nudge an object into motion. Even the faintest tug, billions of years ago, leaves behind a residual spin. Rotation is not an exception. It is the default state of the cosmos. This is why, when astronomers track a new comet or asteroid, one of their first questions is simple: how fast does it rotate? They watch its light. As the object turns, different patches of surface reflect sunlight. Bright zones, dark zones, irregular shapes, all shift in and out of view. The brightness rises and falls in a repeating pattern. This is called a light curve. Plot brightness against time, and you get a wave. Its period reveals the spin rate. Its amplitude reveals the object's shape. It is among the most basic, most reliable measurements in planetary science. But 3i Atlas refuses. According to the leaked post, the object has been scrutinized relentlessly. Hubble tracked it, Webb tracked it, ground-based telescopes followed it through long nights, and its brightness never wavered. We've stared at it for days on end. Its brightness doesn't change, not by a fraction of a percent. It's a dead flat line. Dead flat. No pulse, no variation, no periodic signal, not unusual wrong. Even a perfect sphere, if it has surface texture a patch darker here, brighter there, will betray itself in its light curve. Real comets are not spheres. They are lumpy, cratered, pitted. Jets carve bright scars. Dust accumulates into shadow. All of this creates rhythm, a natural flicker as rotation exposes each face. But 3i Atlas does not flicker. There is one conceivable loophole, an extremely slow rotation. If the spin period stretches to weeks or months, a short observational window might miss a full cycle. But even then, one expects a drift, a gradual change, some slow modulation in brightness. The post insists there is none. The light curve is unwavering, stable, locked. So either 3i Atlas does not rotate at all, nearly impossible for an ancient body that has traveled through countless gravitational interactions, or its brightness is somehow disconnected from its rotation. Either option demands explanation. Now the complication deepens. Both Hubble and Webb recorded a striking feature, a forward plume, a tail pointing toward the Sunday. The natural explanation is a jet. Comets vent when ice sublimates, pressure builds, cracks open, and gas erupts. Dust rides the escaping flow, forming a plume. Jets are directional. They fire from one site, in one orientation. If the nucleus rotates, the jet swings with it, sometimes pointing toward us, sometimes away. The brightness changes in a periodic beat. But here is the contradiction. 3i Atlas has what looks like a jet, but no variation in brightness. Those two observations cannot coexist. The post did not mince words. A jet powerful enough to make the tail would make the object flicker. It doesn't. The explanation for the tail requires a violent directional event. The observation of its light requires a perfectly uniform cloud. You can't have both. One is a lie. Either the model for the tail is wrong, or that cloud isn't natural. Let us unpack that. If the plume is real, driven by a localized vent, then the brightness must pulse, but it does not. So either the plume is not a jet, but something else entirely, or the brightness curve is decoupled from the jet by some mechanism. One option is isotropic outgassing, material venting equally in all directions, a sphere shedding vapor uniformly. That would explain constant brightness, but isotropic outflow produces a symmetric coma and a tail swept back by the solar wind, not a plume pointing into the Sunday. Another option is optical concealment. Perhaps the dust cloud is so thick, so dense, that it smooths away any flicker. The jet might exist, but hidden inside a fog. What we observe would not be the jet itself, but the envelope uniform, smoothed, featureless. But this only shifts the problem. Why would a comet generate such an optically thick shroud, perfectly masking all rotation, while still sustaining a directional plume? Why would two incompatible signatures coexist? This is where the story of 3i Atlas bends again. The comet that does not rotate, yet throws a jet. The plume that demands asymmetry, paired with a light curve that demands perfect symmetry. A paradox suspended in space. That smoothing effect, the idea of a coma so thick it masks rotation, could work in principle. But it requires an immense dust production rate. And the spectroscopic data says otherwise. The coma of 3i Atlas is not dense enough, not optically thick. Which leaves a third possibility, far stranger. That the object is somehow regulating its brightness, actively, maintaining a uniform reflective surface regardless of its rotation or any jet activity. At first, hearing it sounds absurd, but it is the only scenario that allows both observations, the forward plume and the constant light curve, to coexist without dismissing one as error. The insider insists this is the deeper truth, that the rotation anomaly is not isolated at all. It is part of the same system of wrongness, the same hidden machinery that produces recoil, free outgassing, that sheds synthetic chemistry, that generates manufactured dust. And that machinery, they argue, is not solar-powered. It is not driven by heat from the Sunday, it is internal. Which brings us to the thermal ghost. 3. Atlas absorbs gigawatts of solar energy. This is not speculation, it is calculable. Take its cross-sectional area, multiply by the solar flux at 2 astronomical units, and you arrive at numbers in the range of several gigawatts, enough electricity to power a small city. And all that energy has to go somewhere. In a normal comet, the accounting is simple. Sunlight strikes ice, the ice sublimates, and the phase change swallows the energy. Gas streams into space, the comet stays cool. Sublimation is a heat sink. Energy in, vapor out. But for 3I Atlas, the ledger refuses to balance. According to the leak, we calculate the energy budget, and there's a massive surplus. That heat has to go somewhere. It should be driving off enormous plumes of water vapor. But the water isn't there. The James Webb Space Telescope confirmed it. The gas composition is dominated by carbon dioxide, with some carbon monoxide. Water is present, but only in trace amounts. The ratio of carbon dioxide to water is 8:1, staggeringly high. Most comets are water-dominated. Water is the prime volatile. Here, water is a minor player. So again, where is the energy going? One option is radiation. Any object emits thermal radiation proportional to its temperature. If 3I Atlas had a high emissivity, its surface could bleed away heat directly into space, skipping sublimation. But here the spectroscopic data poses another contradiction. The object is cold, too cold, colder than any thermal balance should allow. It's like pointing a blowtorch at an ice cube and watching it refuse to melt, the Post declares. So the picture sharpens. The object absorbs gigawatts, does not release proportionate water, and yet its surface remains frigid. The energy is vanishing. Into what? Into where? The Post offers only one frame: regulation. The object is not passively responding to sunlight, it is controlling its thermal load, maintaining a surface temperature far below equilibrium, either through an extraordinary cooling mechanism or by shunting the energy inward into an internal reservoir, a hidden sink, something that stores energy or transforms it without heating the skin. What natural process could achieve this? Nothing that we know. Not ice, not rock, not any frozen body drifting through interstellar night. And so comes the conclusion, chilling in its bluntness. The gigawatts from the sun are a trivial external variable to a monstrous 3 billion-year-old object with its own power source. It radiates solar energy away passively, like any inert rock would, because the sun is not part of its life cycle. Its own power source, an internal engine. Energy generated from within, independent of solar heat. If that is true, then the thermal regulation ceases to be a mystery. It becomes a side effect. The sun is irrelevant to this body's life cycle. It does not need our star. It is indifferent to it. And that leads to the most disturbing question of all. If 3I Atlas carries an internal power source, what is it? Chapter 6. The Cube Ball Hypothesis. This is the moment when the leaked post veers fully into the territory of physics that sounds more like science fiction than science. And yet, according to the anonymous researcher, it is not an indulgence. It is the only framework that makes the data coherent. It is a macroscopic quantum object, the Post declares. A stable, massive particle left over from the first microseconds of the Big Bang. A bubble of a different set of physical laws that has managed to survive, cloaked in a skin of our reality. The name theoretical physics gives this engine is a non-topological soliton, or more simply, a cue ball. Not a theory, the insider insists. The only known physics that fits. A cue ball. So what does that mean? To answer, we step back to the first instant of time. In the primordial universe, just after the Big Bang, conditions were unimaginable temperatures and densities beyond anything we can recreate in a laboratory. At such energies, the forces we now treat as separate were unified. Particles that we know as distinct quarks, electrons, photons, were merged in a searing plasma. As the universe expanded and cooled, it underwent a series of phase transitions. Symmetries broke, forces decoupled, matter condensed into the forms we recognize. But phase transitions do not always proceed uniformly. Just as water freezing can trap bubbles of liquid inside ice, the early universe may have left behind defects, regions where the transition never fully completed, where the old state persisted, stable pockets of alien physics. These defects have names: cosmic strings, monopoles, domain walls, and cue balls. The jargon can be dense, but the core idea is this: a soliton is a self-sustaining wave, a lump of energy that holds its form because dispersive forces pushing outward are balanced by nonlinear forces pulling inward. Non-topological means it isn't stabilized by geometry, like a knot in a string. Instead, its stability is guaranteed by a conserved charge. In certain theoretical models, particularly supersymmetric extensions of the standard model cue balls can form. They are built from scalar fields, fields with spin zero, fields that carry potential energy. In the right conditions, these fields can settle into a stable configuration, a bubble, where the inside holds a different value than the outside. The bubble doesn't collapse because it sits in a local valley of stability on the energy landscape. The key property, a cue ball, is its own energy source. The field inside decays, but very slowly, leaking energy as particles, as radiation, as heat, over billions of years. A cue ball formed in the infancy of the cosmos could still exist now, ancient and active. This is speculative physics. Cue balls have never been observed. They exist only in equations, in extensions of theory. Most physicists file them under interesting hypotheticals, objects that might exist somewhere, but probably do not. Except, the leak claims, 3I Atlas fits the profile precisely. Let's trace the logic. First, enormous mass in a small volume. Cue balls are dense. The energy field inside is concentrated, compressed. A 3-kilometer cue ball could easily weigh as much as a small moon, 33 billion tons. That is exactly the minimum mass inferred from the lack of non-gravitational acceleration. Second, isotropic outgassing. The decay happens in the core, radiating energy evenly in all directions. That energy warms a mantle of accumulated dust and ice from within. The mantle sublimates, but symmetrically. Gas escapes in a perfect sphere. No recoil, no thrust. The impossible cannon with no kickback is suddenly explained. Newton's third law is satisfied, but the vector sum cancels to zero. Third, constant brightness. If the coma is symmetric, then the object looks the same from every angle. Rotation is irrelevant. The brightness does not flicker because there is no asymmetry to rotate. Fourth, exotic chemistry. The decay of a cue ball does not obey the chemistry of kitchens or laboratories. It is a quantum process, a slow-burn reactor powered by field decay, not by heat. It can generate unusual compounds, like nickel tetracarbonyl, as byproducts of reactions we do not yet understand. The so-called slow-burn reactor, as the insider phrases it, is not a furnace. It is a machine of particle physics, dripping energy steadily into its environment. All of the anomalies, the impossible density, the symmetric outgassing, the unchanging light curve, the strange chemistry become facets of a single hypothesis. 3I Atlas, the anonymous post suggests, may not be a comet at all, but a relic from the first seconds of time, a cue-ball engine, a bubble of alien physics wrapped in the disguise of a comet, drifting through the galaxy for billions of years, still alive. 26 days from now, 3I Atlas will do something that should make everyone uneasy. It will vanish. Not literally vanish, the object will still be there, still racing along its trajectory, but from Earth it will slip into invisibility, hidden behind the blinding glare of the Sunday. On October 24th, 2025, 3I Atlas reaches solar conjunction. Earth, Sun, and object fall into alignment, with our star in the middle. From that day until early December, it is gone from view. No telescope can track its brightness. No spectrograph can sample its chemistry. No radio dish can measure its position. 6 weeks of silence. And in the dead center of that blackout, on October 29th, the object reaches perihelion, its closest approach to the Sun, 1.4 astronomical units, just inside the orbit of Mars. The very moment when solar heating should drive a comet into peak activity. When the jets roar brightest, when its coma blossoms with fury, we will see none of it. This timing has not gone unnoticed. Avi Loeb flagged it explicitly in his October 3rd article. At its perihelion on October 29th, 2025, when it reaches 1.35 astronomical units from the Sun, 3I Atlas will be totally obscured from Earth by the Sunday. If we assume this obscuration occurs within a solar elongation of 30 degrees, then it is straightforward to calculate the likelihood of this alignment with the Sun and Earth as roughly 7%. 7%, not impossible, but not random chance either. 1 in 14. And here the discomfort deepens. If 3I Atlas were a spacecraft, if it possessed propulsion, if it could maneuver, perihelion would be the optimal time to do so. Specifically, to perform what orbital mechanics calls a reverse Oberth maneuver. The Oberth effect is one of the hidden cheats of rocketry. Fire your engines when you are moving fastest, and the change in kinetic energy multiplies. A burst of thrust near periapsis yields more than the same thrust delivered in deep space. This is why spacecraft burn at closest approach. It is the most efficient way to escape a planet or star. That is a standard Oberth maneuver. A reverse Oberth maneuver flips the logic. Imagine an object arriving on a hyperbolic trajectory, bound for interstellar space, but instead of escaping, it wants to stay. At perihelion, moving at peak velocity, it fires its engines not to accelerate but to brake. The velocity reduction is maximized. The hyperbolic path collapses into an ellipse. Escape turns into capture. If 3I Atlas wanted to remain in the solar system, October 29th would be the precise moment to do it, and the maneuver would unfold behind the Sun, hidden from Earth, unobservable. Loeb's framing is careful. He does not claim this will happen. He notes only that the geometry is convenient. This could be intentional, he wrote, to avoid detailed observations from Earth, base telescopes when the object is brightest, or when gadgets are sent to Earth from that hidden vantage point. The optimal point for a reverse solar Oberth maneuver to become bound to the Sun is at perihelion. It is this optimal breaking point for 3I Atlas that is obscured from our view by the Sunday. Gadgets, that is the word he used. Probes, small payloads, shed from the parent body, dispatched toward the inner planets. The retrograde orbit, the planetary alignments, all make the fuel requirements minimal. The calculations already exist. In a July paper co-authored with Adam Hibbert and Adam Kroll, Loeb mapped the delta-v budgets. Delta-v delta velocity is the change in speed needed to reach a target. For 3I Atlas to launch a probe to Mars in early October, the required delta-v is under 5 kilometers per second, achievable with nothing more exotic than chemical propulsion. Venus, the same, less than 5 until July. Jupiter, still less than 5 through November. Earth is harder, always above 5, always more expensive. If one were designing a reconnaissance mission, It would make sense. Visit Mars, Venus, and Jupiter first. Skip Earth for now. Conserve fuel. Decide later if the blue planet warrants the cost. Again, hypothetical. Loeb is not asserting intent. He is pointing out possibility. The trajectory and timing open the door. And here lies the knife edge. We will not know until December. When 3I Atlas re-emerges from behind the sun, it will rise into the pre-dawn sky, low on the eastern horizon, faint but measurable. Astronomers will turn every instrument they can. The first task: measure its position, plot its trajectory, compare with predictions. If the orbit matches the models exactly, if it lies precisely where gravity alone dictates, then nothing happened. It outgassed. It swung past the sun and continued on its outbound track. An unusual comet, still natural. But if the orbit has shifted even slightly, then something did happen behind the curtain. Either the object maneuvered, or it fragmented, or some other event altered its path. Any deviation will matter. Loeb has identified the detection window, November 21st to December 5th. The authors stress that their theory is falsifiable. Should 3I Atlas pass through the solar system without performing unexpected maneuvers, particularly between November 21st and December 5th, 2025, the hypothesis would likely be debunked. 2 weeks. That is the test. If a maneuver occurred, it will show itself by late November. Astronomers will be watching. But this window, this silence, carries another shadow: the precursor probe theory. Chapter 7. The Hidden Maneuver Window. 26 days from now, 3I Atlas will do something that should make everyone uneasy. It will vanish. Not literally vanish, the object will still be there, still racing along its trajectory, but from Earth it will slip into invisibility, hidden behind the blinding glare of the Sunday. On October 24th, 2025, 3I Atlas reaches solar conjunction. Earth, Sun, and object fall into alignment, with our star in the middle. From that day until early December, it is gone from view. No telescope can track its brightness. No spectrograph can sample its chemistry. No radio dish can measure its position. 6 weeks of silence. And in the dead center of that blackout, on October 29th, the object reaches perihelion, its closest approach to the Sun, 1.4 astronomical units, just inside the orbit of Mars. The very moment when solar heating should drive a comet into peak activity, when the jets roar brightest, when its coma blossoms with fury, we will see none of it. This timing has not gone unnoticed. Avi Loeb flagged it explicitly in his October 3rd article. At its perihelion on October 29th, 2025, when it reaches 1.35 astronomical units from the Sun, 3I Atlas will be totally obscured from Earth by the Sunday. If we assume this obscuration occurs within a solar elongation of 30 degrees, then it is straightforward to calculate the likelihood of this alignment with the Sun and Earth as roughly 7%. 7%, not impossible. But not random chance either, 1 in 14. And here the discomfort deepens. If 3I Atlas were a spacecraft, if it possessed propulsion, if it could maneuver, perihelion would be the optimal time to do so. Specifically, to perform what orbital mechanics calls a reverse Oberth maneuver. The Oberth effect is one of the hidden cheats of rocketry. Fire your engines when you are moving fastest, and the change in kinetic energy multiplies. A burst of thrust near periapsis yields more than the same thrust delivered in deep space. This is why spacecraft burn at closest approach. It is the most efficient way to escape a planet or star. That is a standard Oberth maneuver. A reverse Oberth maneuver flips the logic. Imagine an object arriving on a hyperbolic trajectory, bound for interstellar space, but instead of escaping, it wants to stay. At perihelion, moving at peak velocity, it fires its engines not to accelerate, but to brake. The velocity reduction is maximized. The hyperbolic path collapses into an ellipse. Escape turns into capture. If 3I Atlas wanted to remain in the solar system, October 29th would be the precise moment to do it, and the maneuver would unfold behind the sun, hidden from Earth, unobservable. Loeb's framing is careful. He does not claim this will happen. He notes only that the geometry is convenient. This could be intentional, he wrote, to avoid detailed observations from Earth, base telescopes when the object is brightest, or when gadgets are sent to Earth from that hidden vantage point. The optimal point for a reverse solar Oberth maneuver to become bound to the Sun is at perihelion. It is this optimal breaking point for 3I Atlas that is obscured from our view by the Sunday. Gadgets, that is the word he used. Probes, small payloads, shed from the parent body, dispatched toward the inner planets. The retrograde orbit, the planetary alignments, all make the fuel requirements minimal. The calculations already exist. In a July paper co-authored with Adam Hibbert and Adam Crowell, Loeb mapped the delta-v budgets. Delta-v delta velocity is the change in speed needed to reach a target. For 3I Atlas to launch a probe to Mars in early October, the required delta-v is under 5 kilometers per second, achievable with nothing more exotic than chemical propulsion. Venus? The same, less than 5 until July. Jupiter? Still less than 5 through November. Earth is harder, always above 5, always more expensive. If one were designing a reconnaissance mission, it would make sense. Visit Mars, Venus, and Jupiter first. Skip Earth for now. Conserve fuel. Decide later if the blue planet warrants the cost. Again, hypothetical. Loeb is not asserting intent. He is pointing out possibility. The trajectory and timing open the door. And here lies the knife edge. We will not know until December. When 3I Atlas re-emerges from behind the sun, it will rise into the pre-dawn sky, low on the eastern horizon, faint but measurable. Astronomers will turn every instrument they can. The first task, measure its position, plot its trajectory, compare with predictions. If the orbit matches the models exactly, if it lies precisely where gravity alone dictates, then nothing happened. It outgassed, it swung past the sun and continued on its outbound track. An unusual comet, still natural. But if the orbit has shifted even slightly, then something did happen behind the curtain. Either the object maneuvered, or it fragmented, or some other event altered its path. Any deviation will matter. Loeb has identified the detection window, November 20, 1st to December 5th. The authors stress that their theory is falsifiable. Should 3I Atlas pass through the solar system without performing unexpected maneuvers, particularly between November 21st and December 5th, 2025, the hypothesis would likely be debunked. 2 weeks, that is the test. If a maneuver occurred, it will show itself by late November. Astronomers will be watching. But this window, this silence, carries another shadow. The precursor probe theory. Chapter 8. The decoy scenario. There is a theory within the theory, a speculation folded inside the speculation, and it may be the most unsettling of all. What if 3I Atlas itself is a distraction? The idea comes from Omar El-Dadi, a collaborator of Avi Loeb's. He proposed that an advanced civilization might use something that looks perfectly natural, an interstellar comet, as a decoy, something bright, something obvious, something irresistible to telescopes and media. Meanwhile, the real operation happens elsewhere. Loeb discussed this in an August blog post. My collaborator, Omar El-Dadi, suggested that aliens might use a natural interstellar comet as a decoy to attract our attention when they conduct another operation at a different location near Earth. Given that perspective, it would be interesting to check whether there is an enhanced activity of unidentified anomalous phenomena in the Earth's atmosphere in the aftermath of the closest approach of 3I Atlas to the Sun on October 31, 2025. Enhanced UAP activity. Around the time of perihelion, that's testable. and someone is testing it. The Galileo Project Loeb's initiative is an astronomical research program designed to search for evidence of extraterrestrial technology, not in radio signals from distant stars, but here, near Earth. It uses telescopes and sensors to monitor the sky for anomalous objects. The project currently operates 3 observatories, one at Harvard College Observatory in Massachusetts, one in Pennsylvania, and one in Nevada. Each is equipped with cameras, infrared sensors, radar, and audio detectors. Together they scan the sky continuously, recording everything that moves overhead. Artificial intelligence sorts the stream birds, planes, satellites, drones, meteors. Most objects are mundane, most are explained, but occasionally something appears that does not fit an object moving too fast or too slow or changing direction in ways conventional aircraft cannot. Those anomalies are flagged, analyzed, investigated. Since late 2022, the Galileo project has compiled data on 500,000 aerial objects. The vast majority have been identified. Nothing unusual. But the system exists, watching, and according to Loeb, it will be watching closely through October and November. Gladly, he wrote, the Galileo project will be monitoring the sky under my leadership with its 3 observatories in Massachusetts, Pennsylvania, and Nevada during that period. If UAP activity increases, if something strange begins to appear in Earth's atmosphere while 3-1 Atlas is hidden behind the Sun, the Galileo project should catch it. If the timing aligns, it would be, at the very least, interesting. To be clear, Loeb is not predicting alien spacecraft. He is not saying 3I Atlas is a decoy. He is saying that if it were, we should look for secondary activity. And his team is positioned to do exactly that. The decoy hypothesis rests on a few assumptions. First, that 3-1 Atlas is either artificial or controlled. Second, that its purpose is not direct contact, but reconnaissance. Third, that whoever sent it, or whoever is using it, wants humanity distracted, focused on the big, obvious object, while smaller, stealthier operations unfold closer to home. Why would an advanced civilization do that? One reason is information asymmetry. If you are scouting a potentially unpredictable species, you do not announce yourself. You gather data quietly. You deploy small probes with low observability, and you ensure your target's attention is elsewhere. 3I Atlas is loud, bright, unusual. Every major telescope on Earth and in orbit has looked at it. Papers are being written. Scientists are debating. Media is framing it as a spectacle. And while everyone stares upward at the comet, what is happening down here in the atmosphere, in orbit? Are there small objects, quiet objects, doing things we are not noticing? The Galileo project's data may tell us. Or at least, it will tell us if there is an uptick, a statistical anomaly, more unexplained objects than usual, a clustering around late October, early November. If that happens, it would not prove the decoy hypothesis. Correlation is not causation, but it would be difficult to ignore. There is another angle, the stealth hybrid spacecraft theory, proposed by Gabor Soka, a reader of Loeb's work. The idea is that an advanced civilization might not build spacecraft from scratch. They might use what nature provides: asteroids, comets, and repurpose them, terraform them, hollow them, install machinery inside, use the natural exterior as camouflage. Loeb quoted Soka in his blog, "Humanity is already planning asteroid mining missions, and for a more advanced civilization this could be a straightforward method. An asteroid hull provides excellent natural shielding. The stealth advantage is built in. As long as the object emits nothing artificial, no radio signals, no reflective panels, no unnatural surfaces, it appears indistinguishable from a rock. A natural asteroid, a harmless comet, and that solves a critical problem. If you want to send something across interstellar space, you need shielding, cosmic rays, high-energy particles, micrometeoroids. The void is hostile. To survive millennia in transit, a craft would need walls meters thick. Building such armor is expensive. heavy. But start with a rock, and the shielding is already there. Excavate the interior, hollow out a cavern, install your systems, propulsion, sensors, power. From the outside, it remains a comet. It outgasses, it grows a coma, it does all the things comets do. But inside, machinery, instruments, power sources, perhaps even a crew, dormant, waiting. This is not a new speculation. Science fiction has long toyed with the idea. Arthur C. Clarke's Rendezvous with Rama, a massive cylindrical craft disguised as an asteroid. Greg Bear's Forge of God, self-replicating machines hidden inside icy bodies. The motif is familiar, but also practical. If you are crossing interstellar gulfs, if your journey takes centuries or millennia, using natural material makes sense. You gain shielding, you gain camouflage, and you make detection harder, because astronomers assume rocks are rocks. Unless they do something unambiguously artificial, they are catalogued as natural. 3. Atlas has done nothing overt. No signals, no deliberate course changes, no lights, nothing to betray it as a machine. And yet it doesn't quite fit. Its chemistry is off, its physics is off, its trajectory is suspicious. But none of these things rise to the level of proof. That is the brilliance of a stealth hybrid design. It is deniable, ambiguous. You cannot prove it artificial without an intercept, without closing the gap, and by the time humanity could launch a mission, it will be gone, racing outward into the dark, out of reach. So we wait, suspended in the ambiguity. Will the Galileo project see something unusual in the coming weeks? Will reports of unidentified aerial phenomena increase? Will objects appear that do not fit into the categories of bird, plane, satellite, or meteor? And if they do, will anyone connect them back to 3I Atlas? Or will October and November pass quietly? No uptick, no anomalies, just a comet hidden behind the sun, reappearing on the far side, strange but still natural. The data will decide, one way or another. We only have to wait a few more weeks. Chapter 9. The Silence Protocol. The scientific community is fractured, not in the way the public sees, not in press conferences or official NASA briefings, but in the quieter spaces. In the email threads that don't leave the building, in whispered conversations in the hallways of conferences, in late-night arguments over coffee in half-lit labs. There are two camps, and the distance between them is widening. One side says 3I Atlas is a comet. Unusual, yes, pushing the boundaries of known chemistry and physics, but still natural. The anomalies can be explained with exotic parent molecules not yet identified. The mass estimates might be wrong, based on flawed assumptions. More data will fix the picture. Be patient, trust the instruments, let the models converge. The other side is less certain. They see the same data, run the same calculations, but their results don't fit, not at the edges, at the core. The physics breaks unless you accept premises that seem impossible. Massive densities, internal energy sources, synthetic chemistry, things that belong to industry or particle physics labs, not frozen rocks from the void. The leaked 4chan post gave this tension a voice. The official position is that 3I Atlas is a uniquely active but otherwise natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for a growing number of us. Cognitive dissonance. That's not a casual phrase. It means holding two contradictory beliefs at once. Believing the data is accurate, but also believing the object is natural. If the data is right, natural doesn't work. If natural is right, the data must be wrong. And yet the data has been checked, repeatedly, by independent teams, different instruments, different methods, and it keeps coming back the same. So where does that leave the scientists caught in the middle? According to the Post, they're being discouraged from discussing alternatives, not forbidden, not censored, just discouraged. The professional incentives lean toward conventional explanations. A paper that uses words like artificial or non-natural draws harsher reviews. A grant application with alien technology, anywhere near it, struggles to survive committee. Careers can stall on speculation. This isn't unique to 3i Atlas. It's a structural issue in science. Conservatism is built into the system. Most of the time, that's a safeguard. It prevents wild theories from drowning out solid work. But occasionally it creates blind spots. Data points in one direction, the community insists on looking in another. Jason Wright, astronomer at Penn State, has been one of the more vocal critics. He's clashed with Avi Loeb for years, first over Oumuamua and now over Atlas. In a recent blog post he wrote, "Avi Loeb has gained a reputation for suggesting and outright claiming that things could be alien spacecraft, even when there's little to no objective reason to think so." It didn't take long before he claimed 3i Atlas was an alien spacecraft. Wright points out specifics. The extended source seen in telescope images? Loeb's suggestion that it might be a smear effect is wrong, Wright says. Modern telescopes compensate for motion. They track, they stack exposures, they eliminate smear. If multiple independent observatories see an extended coma, it's real. 3i Atlas has a coma. That makes it a comet. But Loeb's position is more nuanced than Wright gives credit for. He isn't declaring certainty. He's introducing a scale, the Loeb scale, ranging from 0 to 10. 0 means definitely natural. 10 means definitely artificial. He places 3i Atlas at 6, not proven, not certain, but high enough to warrant serious attention. It's a way of breaking the binary trap, not alien or not, but how anomalous is it? And how much should we invest in studying it? Loeb has gone further, proposing that the scale itself should be adopted formally by an international body. In October, a white paper was submitted to the United Nations, authored by Loeb, Omer Eldadi, and Gershon Tenenbaum. Its title, Advancing Interstellar Science, a global framework for the comprehensive study of interstellar objects. The proposal, create UNSCHO, the United Nations Committee on Interstellar Objects. The logic is simple. Detection capabilities are about to jump. The Vera Rubin Observatory in Chile, scheduled to come online in 2025, will scan the entire sky every few nights, detecting faint moving objects no telescope has ever caught before. Estimates suggest we'll find interstellar visitors not once a decade, but once every few months. A steady stream of Oumuamuas and Borisovs and Atlases, each one fleeting, each one a chance to study material from beyond the solar system. But the window is always short. They whip past the sun and are gone. If we want to seize those chances, we can't afford fragmented national responses. We need coordination, rapid, pre-planned, international. That's the pitch, and behind it is a deeper recognition. The next anomaly could be bigger, stranger, less deniable. And when it comes, the scientific community cannot afford to be caught paralyzed between camps, trapped in silence, or splintered by professional incentives. The silence protocol, as the Post calls it, isn't about censorship. It's about hesitation, about the gravitational pull of conservatism in science, the reflex to explain anomalies away rather than confront what they might mean. And 3i Atlas is forcing the issue. UNCO, on paper, reads like something from a near-future thriller, an international command center for interstellar anomalies. The proposal would standardize the response, write protocols in advance, instead of improvising them in panic. It would build a network of observatories with guaranteed time on the sky, maintain a fleet of rapid response spacecraft sitting on launch pads or tucked inside fairings, ready to lift off at weeks' notice, and, most controversially, it would make the Loeb scale an official classification system. Under the draft, any object rated 4 or above would trigger enhanced observation. Level 6 would require notification of the UN Security Council. Level 8 or higher would activate emergency protocols. 3i Atlas currently sits at 6, a category reserved for things that look natural but behave in ways the models cannot reconcile. If it maneuvers, if gamma rays are detected, if its activity continues independent of solar distance, the number rises, and with it, the international response. It's an ambitious framework. It would need funding, political will, and cooperation among space agencies that rarely share data without a fight. None of that is guaranteed. Yet the architecture exists on paper, and Representative Anna Paulina Luna, a US Congresswoman, has already attached her name to it. Her letter of support is quoted in the white paper. Whether UNCO becomes reality now depends on how the next few months unfold. If 3I Atlas fades quietly into the outer dark, the urgency evaporates. It becomes an interesting case study, a weird comet, a handful of papers. If, however, the object behaves in ways that defy explanation, the conversation shifts. Suddenly, international coordination doesn't sound like bureaucratic overreach. It sounds necessary. But the real hinge of this story isn't just policy, it's transparency. Or rather, the lack of it. The leaked 4chan post hints at internal conversations that aren't public, at datasets that haven't been released, at frustrations kept off the record. If that's true, if there's a gap between what scientists are saying privately and what they state officially, that gap cannot last forever. It closes either through leaks or through formal disclosure. Science runs on openness. Data should be shared, hypotheses tested in public, peer review conducted in daylight. When that breaks down, trust erodes. Speculation seeps in to fill the void. Right now, we're in a strange middle ground. Enough data is public to raise questions, but not enough to answer them. The critical observations, the Mars flyby images, the gamma-ray searches, the December trajectory measurements are still pending. And in that gap, people are waiting. Some with telescopes, some with theories, a few, allegedly, with knowledge they're not supposed to share. The next chapter of this story will not be written by speculation. It will be written by data, by images, spectra, and orbital elements that either confirm the conventional explanation or force us to consider alternatives. We are close now. The Mars flyby happened today. The perihelion window is 3 weeks away. The December emergence is 2 months out. By the end of the year, we will know more, perhaps not everything, but more. And if the anomalies persist, if the data keeps refusing to cooperate, then the silence protocol, whatever form it takes, will not hold. Because eventually the walls we build around uncomfortable questions begin to crack. And when they do, the shape of the room becomes visible, whether we're ready to see it or not. Chapter 10. What happens next? The waiting has begun. The first results should come quickly. Within days, perhaps a week, the Mars Reconnaissance Orbiter will finish transmitting its data. Engineers are already processing, calibrating, stripping out noise. Then, for the first time, the cameras of HiRISE will show us what passed Mars on October 3rd. If the nucleus appears sharp, round, and at least 5 kilometers across, the debate over mass hardens into fact. 33 billion tons becomes unavoidable. The odds of finding something that large by chance collapse. Either the galaxy is littered with giants, or this object is exceptional in ways no model can explain. But if HiRISE shows a nucleus under a kilometer wide, the mystery shifts shape. A small body producing this much outgassing, sustaining this brightness at these distances, would demand a different kind of explanation. Not mass, but activity. Not improbability, but impossibility. Internal heat. An engine. Something beyond the reach of solar warming alone. The chemistry will soon follow. Mars Express and the ExoMars Trace Gas Orbiter carry instruments designed to dissect atmospheres molecule by molecule. Pointed outward, they may catch spectral fingerprints that Earth-based telescopes missed. If exotic compounds appear, if the nickel story deepens, if the ratios sharpen further out of line, the anomaly grows. Meanwhile, Earth's telescopes count down the hours. Photometers measure brightness nightly. Spectrographs rake the spectrum for subtle changes. Polarimeters probe the dust. Every data point adds to a pre-perihelion timeline, a living ledger of behavior. That ledger will become the yardstick when 3I Atlas re-emerges in December. Does the curve track the standard cometary power law activity, rising as distance falls, then fading as it recedes? Or does the outgassing stay stubbornly high, indifferent to solar input? A comet obeys the Sunday. A cue ball does not. By January or February, the answer will be written in the light curve. Then there is the invisible hunt. Fermi and Integral scan the sky every second for high-energy photons. If 3I Atlas carries an internal decay engine, its heartbeat may reveal itself not in dust or jets but in gamma rays. So far, no public detections. But gamma-ray astronomy is patient work. Signals hide in noise. Datasets sit waiting for eyes to notice. A faint, persistent emission from the coordinates of 3I Atlas would be impossible to explain away. Comets do not make gamma rays. Pulsars do. Magnetars do. Supernova remnants do. Or perhaps something stranger. Gravity itself will testify, slowly. On October 3rd, the object passed within 29 million kilometers of Mars. If the mass really is in the tens of billions of tons, Mars will feel a tug. Not dramatic, not cinematic, but subtle, adrift in orbital elements, millimeters per day. Yet the red planet's path is tracked to exquisite precision. By early 2026, if the perturbation appears, it will confirm the mass in a way no spectrometer can. At the same time, down here on Earth, a different experiment is already running, the Galileo Project. 3 observatories in Massachusetts, Pennsylvania, and Nevada, scanning the sky with AI filters. Every object classified, every anomaly flagged. If October and November bring a spike in unexplained aerial events, if the statistics suddenly jump, the decoy hypothesis will gain a new layer of credibility. If the numbers remain flat, the theory weakens. Either way, the data will be public. And then comes December 5th, the end of the window. By then, the object will be visible again in the pre-dawn east. Observatories will lock on. Ephemerides will be checked. If the orbit is unchanged, if it flows along the predicted gravitational path, the comet hypothesis holds. Strange, yes. Exotic, yes. But natural. If the orbit has shifted even by a fraction, then something happened behind the Sun, at perihelion, hidden from Earth. A burn, a fracture, a maneuver. Whatever it was, it will demand an explanation. The coming months are not speculation. They are tests, timelines, predictions, falsifiable claims. The data is coming, step by step, in layers. Images, spectra, photometry, gamma rays, gravity. By early next year, one of two things will be true. Either 3I Atlas fades quietly into the cold beyond, just another comet, or it refuses to behave like anything nature makes. And if it refuses, then the story we've told ourselves about the universe, about what drifts through the dark, will need to change. And now the Vera Rubin Observatory has entered the story, a new eye opening just as 3I Atlas drifts past Mars. Rubin is not a telescope in the old sense, a single observer peering at a single target. It is a sweep, a nightly census of the entire sky, deep imaging at unprecedented cadence. Algorithms scan its images automatically, flagging anything that moves. Asteroids, comets, interstellar visitors. The models predict one new interstellar object every few months once Rubin reaches full capacity. In a year or two, we may have dozens, a catalogue where today we have 3. That prospect reframes everything. Is 3I Atlas an outlier, a freak of celestial dice rolling, or the first clear glimpse of a hidden population, massive objects that have always been there, invisible because our instruments weren't sharp enough to notice? If the next few interstellar visitors behave like textbook comets, small, icy, fading with distance, then 3I Atlas becomes a mystery that deepens rather than dissolves. If instead they echo its properties: extreme mass, synthetic-looking chemistry, unblinking brightness, then 3I Atlas was never an exception. It was a preview. Either way, we've crossed a threshold. For the first time in human history, we can study these wanderers in detail, not just detect their streaks of light. Spectroscopy, high-resolution imaging, rapid response missions, international coordination. Every instrument is being pushed to its limits. Every model is being stress-tested, and in the stress fractures, the gaps of our knowledge show through. Chemistry that shouldn't exist, dust that behaves like smoke, physics that seems to fold back on itself. Some of those gaps will close as better data arrives. Others may widen into chasms. At some point, the question ceases to be, "What kind of comet is this?" and becomes simply, "What is this?" We are not at that point yet, but we are close enough to see the edge. Over the next 3 months, the puzzle will either resolve or harden. The Mars images, the perihelion passage, the gamma-ray searches, the December re-emergence, the Galileo project's UAP data, each will add a tile or crack the mosaic further. By March, when 3I Atlas passes Jupiter and Juno gets its look, we'll have a clearer picture. If by then the object still sits at 6 or higher on the Loeb scale, the silence protocol cannot hold. Because what began on October 3rd, 2025, a comet passing Mars, a leak on an obscure message board, may prove to be more than a curiosity. It may be a glimpse beneath the surface of our own models, an encounter with something older than planets, older than stars. The universe is patient, it does not rush, but it also does not hide. If 3I Atlas carries a secret, it will reveal itself, not in a flash of disclosure, but in the slow, relentless accumulation of data. And that, ultimately, is the heart of science. Not an archive of answers, but a method for asking sharper questions and for following the answers, even when they lead somewhere uncomfortable. So here we stand. October 3rd, 2025. The flyby is over. Data is streaming back across the void. In that stream may lie an answer, or the beginning of one. Until then, we watch, and we wait, and we let the question hang in the darkness. What are you, 3I Atlas? And then there is the leak. An anonymous post dropped onto the digital back alleys of 4chan, claiming to come from someone inside the European Space Agency. The voice in the text was weary, frustrated, but precise. They described a working group that had tried, for months, to fit this object into any known category of natural body and failed. They described chemistry that does not belong on a rock billions of years old, dust that looks manufactured, a thermal budget that will not balance, and a conclusion quietly discouraged from discussion. Perhaps this is not debris at all. The name they gave that conclusion is stark: the cube ball hypothesis, a macroscopic quantum object, a relic of the Big Bang itself, a bubble of alien physics wrapped in a skin of ice and dust, decaying slowly across billions of years. An engine that requires no sunlight, a machine whose exhaust is exotic chemistry, a body that vents gas violently and symmetrically, with zero recoil. It sounds like science fiction, but according to the leaker, it is the only physics that makes the data cohere, the only framework that turns a system of wrongness into something logical. And here is the crucial point. It is testable. 2 predictions, simple and falsifiable. Watch the object as it leaves. If its activity persists at impossible levels, independent of solar distance, that is the first sign. Point a gamma-ray telescope at it. If a non-thermal high-energy signal appears, that is the second. Both predictions will be tested in the coming months. Then comes the hidden window. In 26 days, 3I Atlas slips behind the Sunday. On October 29th, it reaches perihelion, its closest approach. If maneuvers are possible, this is the perfect moment to brake. If probes exist, this is the perfect moment to release them, and we will see none of it. Not until December, when the comet re-emerges, and astronomers check its trajectory. Did it shift? Did something happen in the glare? The decoy theory adds another layer. Maybe 3i Atlas is a distraction, a loud, obvious spectacle designed to draw our gaze, while the real reconnaissance happens closer to Earth. Avi Loeb has written about this. Omar El-Dadi suggested the idea. The Galileo project, Loeb's own initiative, is watching. 3 observatories, scanning the sky with cameras, infrared sensors, radar, and AI classifiers. If anomalous aerial phenomena increase around perihelion, the data will show it. And beneath all of this, the scientific community is fracturing. Not in press conferences, not in journal abstracts, but in hallways and private threads. Some insist it is a comet, unusual but natural, explainable with exotic chemistry or revised models. Others stare at the same data and cannot make it fit. The phrase from the leak still echoes: cognitive dissonance. Believing the measurements while also believing the cometary hypothesis, even when the two no longer reconcile. And silence, from leadership, grows louder. Researchers discouraged from saying the word artificial. Papers carefully phrased to avoid speculation. Careers delicately balanced against data that refuses to behave. Out of this tension comes a proposal, UNCIO, the United Nations Committee on Interstellar Objects, a framework for coordination on a planetary scale. The Loeb scale adopted formally as a classification tool. Objects rated 4 or above triggering enhanced observation. Level 6, requiring Security Council notification. Level 8, activating emergency protocols, rapid response spacecraft pre-built and waiting for launch. Global observatories linked in a shared network. And why? Because the next one is coming. The Vera Rubin Observatory guarantees it. Rubin's nightly sweeps will find interstellar visitors at a steady rhythm, perhaps one every few months, perhaps more. Each one a chance or a warning. Each one demanding rapid action. Right now, 3i Atlas sits at a 6. Enough to warrant serious attention, not enough to trigger alarms, but the scale is flexible. If gamma rays appear, if its trajectory changes, if its activity persists independent of distance, the rating climbs and the conversation escalates. We are about to learn something. In the next 3 months, data will arrive that either confirms the cometary explanation or forces us to look elsewhere. Mars images will show the nucleus large or small. Spectroscopy will refine the chemistry. December trajectory checks will reveal if anything happened in the hidden window. Gamma-ray searches may find a signal or rule it out. The Galileo project will either see a spike in anomalies or nothing at all. And by spring, when 3i Atlas passes Jupiter and the Juno spacecraft takes its shot, the dataset will be complete enough for confidence. Not final certainty, perhaps, but clarity. Enough to say what this object is, or at the very least, what it is not. The universe does not lie. It may delay, it may cloak its patterns in paradox, but it does not lie. If 3i Atlas is simply a comet strange, yes, but natural, the data will converge. The anomalies will soften, the models will adapt, and we will move on. If not, if the anomalies persist, if each new observation deepens the system of wrongness, then we must follow where the evidence points, even if it takes us into places we have never imagined. That is the promise of science. Not comfort, not certainty, but truth, however strange. So here we are, at the edge of the story, October 3rd, 2025. The Mars flyby is already history. Data streams silently across millions of kilometers, bits of light carrying possible answers. Somewhere inside that stream is the beginning of clarity.